This is Mr. Hill with another linear relations tutorial. So by the end of this video, students will apply data management techniques to investigate relationships between two variables. It will demonstrate an understanding of constant rate of change and its connection to linear relations. Students will connect various representations of a linear relation and solve problems using the representations. So the specific expectation will pose problems, identify variables, and formulate hypotheses associated with relationships between two variables. So our sample problem, we're continuing with the pizza problem, and we're asking the question, is the relationship between the number of toppings and the cost of a pizza linear or non-linear? Okay, we might extend this question also to ask, how much would it cost for a topping for a pizza with 10 toppings? Okay, so let's have a look. So I just want to recap quickly what happened in the last pizza problem. Michael got his first job, and he needed to create a menu that displayed the cost of a pizza for up to 5 toppings. Okay, so we created a table and we listed the number of toppings in one column and the cost of the pizza with that number of toppings in the second column. We also noticed that we had a base cost here, the cost of our cheese pizza, and we also found out that the cost per topping represented our rate of change. So to answer the question, is the relationship between the number of toppings and the cost of the pizza linear or non-linear? Let's try and graph this and see what it looks like on a graph. So I took the time and I cleaned up our table a little bit. Remember that as we increase the number of toppings by 1 each time, we increased the cost of the pizza by 2. The first point is 0.14. Well, we can let x represent the number of toppings and y represent the cost of the pizza. So remember, if we have 0 toppings, the cost is $14. So here's 0, right? 0 toppings, we have $14. If we have 1 topping, our cost is $16. 1 for x, 16 for y. When we have 2 toppings, our cost is $18. 2 for x and 18 for y. If we have 3 toppings, our cost is $20. If we have 3 toppings, our cost is $20. Now I want to stop here, and I just want to show you what does this represent. As we're increasing our toppings by 1 each time, we can draw a nice little straight line. Right, we've increased our toppings by 1 each time. Right, here's our +1, and we increased our cost by 2. Now I'm just going to label that our +2. And notice this pattern continues. As I increase the number of toppings by 1 each time, I increase the cost by 2. Increase the number of toppings by 1 each time, and the cost by 2. Now this little step method is very useful for predicting our next number on the graph. Even though we know that our next number is 422, let's just show you how we can use this little step method. So as I increase the number of toppings by 1 each time, I'm increasing the cost by 2. And there we end up at our next point, 422, which matches the next point in our table, 422. So we can also use this step method to find the cost of the pizza with 5 toppings. As we add 1 topping, we increase the cost by 2. And we end up at the point 524. I want to go over these points just so they're nice and clear. So we can come back to the question, is this relationship linear or non-linear? So let's take out our straight line tool. If I connect each point, or I connect my first point to my last, I see that I can connect a nice straight line through all the points on my graph. This means that our relationship is linear. So if I wanted to describe it, I could say that we have a linear relationship. Why does this matter? Why is this important? You could also extend it to ask further questions about what would the cost be, or make some predictions about the cost be for an 8-topping pizza. So one of the things that you could do is actually continue using this step method. And this step method is really important in linear relations, and we'll come to understand this horizontal increase is called our run, and this vertical increase is called our rise. And these both contribute to what we'll come to understand as the slope of a line. And but just if we wanted to, for the sake of extending this problem, what would the price of an 8-topping pizza be? Well, I can continue counting over. As I increase the number of toppings by 1, I increase the cost by 2. So right now you see here we're at 7 toppings, but let's see what happens to get to 8. So we can use this to get to the point 8, and I'm going to use a nice straight line to show you that it points to the y value of 30. So what is the cost of an 8-topping pizza? Well, the cost is $30. So this is a nice little recap of some of the things that we've been doing with linear relations, and let's talk about how we can use some of this information and relate it to the equation of a line. Okay, because this is extending it to another level of understanding that can incorporate our rate of change and our base cost. And this base cost is really important, and we'll see that one of the components that we need to write an equation in slope-intercept form. So thank you for watching, and stay tuned, and we will continue working on this pizza problem, and hopefully it helps, and continue watching and enjoy.